Okay, so welcome to Unit 8 of Regents Chemistry, and this is Oxidation Reduction Lesson 2. And so today we're going to look at oxidation reduction, at an oxidation reduction reaction. We're going to define oxidation reduction, and we are actually going to start to develop half reactions for both oxidation and reduction. Okay, so we'll start off with the major understanding. An oxidation reduction reaction involves the transfer of electrons. Reduction is the gain of electrons. Oxidation is the loss of electrons. And in a redox reaction, the number of electrons lost is equal to the number of electrons gained. Okay. So we're going to first look at this reaction above right here. And we're going to start off by assigning oxidation states to the atoms in the chemical equation. I'm going to go kind of quick here because we discussed this in lesson 1. So if you're still struggling with that, you can go back and look at lesson 1. Okay, so to begin, any pure substance has a oxidation number of 0. And so any element by itself has an oxidation number of 0. So here, our solid sodium has an oxidation number of 0. Okay. If we look up oxidation states for atoms on the New York State chemistry reference table, we will see that silver has only one oxidation state, which is +1, and oxygen has only one oxidation state, which is -2. Okay. The whole entire compound, AgClO3, has to have a neutral oxidation state of 0. And so we can do simple algebra here to determine that our oxidation state of chlorine here is going to be +5. Okay. Now, if we look at the product side of the reaction, we'll see that silver is all by itself, so it has an oxidation state of 0. Oxygen, again, is always -2. And sodium here has an oxidation state. If you just look at the New York State chemistry reference tables, you'll see that sodium has only one oxidation state, which is +1. Okay. Again, it's important to note that generally the atom that appears first in the compound has a positive oxidation state, and the atom that appears last in a compound has a negative oxidation state. However, any atom in the middle can have either positive or negative. And here we find that chlorine has a +5 oxidation state again. Okay. So looking at this, we see that the oxidation numbers for sodium and the oxidation numbers for silver change. Okay, so oxidation numbers for sodium and silver change. Okay, and so those are oxidation reduction agents. Everything else where their oxidation states don't change, those are called spectator ions, and we can ignore them when we write half reactions. So for instance, chlorine is +5 here and +5 here. Oxygen is -2 and -2. The oxidation states don't change. They're neither gaining or losing electrons, so we don't need to consider them when we're talking about oxidation and reduction. Okay. So we're first going to start off with our substance or our atom that's losing electrons. Okay, and so loss of electrons is oxidation. Okay. And so we can, if we look at sodium, sodium goes from Na0 to Na+1. And so what actually happens here is it lost one negative electron. Okay, so we're only then going to consider sodium. And so sodium here has an oxidation state of 0. Okay, and then we have our arrow here. We're going to pull that down also. And now we have sodium with a +1 oxidation state. Okay. All right, and so this happened because sodium lost 1 electron. So the way we write this half reaction is we just add 1 electron to the product side to show that electron is being lost. Okay, and you can represent electrons as E negative, we've mentioned before. Okay, and so what's happening here is 1 electron is lost. Okay. And it's important to note here that because we're losing an electron, our oxidation number actually increases. So for oxidation, our oxidation number increases. So oxidation number increases. Okay. So now let's consider what's happening with silver. Okay, so silver is going from Ag +1, okay, to Ag0. Okay, and so its oxidation number is being reduced. Its oxidation number is getting smaller. Okay, so but this is happening because it's gaining a negative electron. So we say gain of electrons is reduction. Okay, and there's a memorization device that you can use so that you can remember this. So we can say Leo says, okay, so loss of electrons is oxidation, gain of electrons is reduction. Okay, and so to represent that electrons are gained by silver, we're going to add them to the reactant side. So we're going to add 1 electron to the reactant side. Okay, and so what happened here is our oxidation number decreases or is reduced. Okay, and 1 electron is gained. Okay, now it's important to note here that sodium lost 1 electron and silver gained 1 electron. Okay, so the amount of electrons lost are equal to the amount of electrons gained. Okay, so now let's look at another reaction below here, and let's assign oxidation states. So again, chlorine is the last atom, so it has to have a negative oxidation state, and the only negative oxidation state for chlorine in the New York State chemistry reference tables is -1. So hydrogen's positive here, so it'll be +1. Okay. Sodium here is going to be +1. Okay. Chlorine is, I'm sorry, chlorine. Oxygen is -2. Okay. Now, since oxygen has to be -2, sodium has to be +1. That means hydrogen has to be +1 here. So again, hydrogen breaks the rule. Usually the last atom is negative. However, hydrogen will break this rule from time to time. Okay. And now sodium, again, only positive oxidation states +1. Chlorine, only negative oxidation states -1. Oxygen is always -2. This whole compound has to equal 0. So that means each hydrogen has to be +1. Okay, so looking at this, you'll see there are no changes in oxidation states for any of the atoms in the chemical equation. Hydrogen's +1 here, it's +1 here. Chlorine's -1 here, chlorine's -1 here. Sodium's +1 here, sodium's +1 here. Okay, and so since there's no change in oxidation numbers, this is not redox. So no change in oxidation numbers. So this is not redox. Okay. So one of the quick ways to check and see if something is a redox reaction is simply for looking for substances where the atoms we have a single atom all by itself. Okay. So here you have elemental sodium. Here you have elemental silver. So you know that these oxidation states are 0. However, when they are then in compounds, we now know that their oxidation states are not 0. So we know their oxidation states changed. Okay. The reaction down here, this one right here, is what's called a neutralization reaction. And here, there is no exchange of electrons. And so because of that, it's not a redox. Another example of a type of equation that's not a redox would be a double replacement reaction. Okay. And so that is lesson 2 of oxidation reduction. In the next lesson, we'll focus more on writing redox half reactions. Thank you.